Hello everyone. In this chapter, we are going to look at bandpass modulation and demodulation. Some specific questions asked from this chapter. Okay, the first type is this. The question is, in a digital communication system, the bit rate of bipolar NRZ. Bipolar NRZ, we saw it in the previous video. Okay, so bipolar NRZ data sequence is 1 Mbps and carrier frequency of transmission is 100 megahertz. Determine symbol rate and bandwidth requirement of 8 ARY PSK system and 16 ARY PSK. What is PSK? PSK is nothing but phase shift keying. We have ASK, which is amplitude shift keying. We have PSK, which is phase shift keying. We also have FSK, which is frequency shift keying. So let's look how to solve this. First thing, the thing that I have underlined is bipolar NRZ data sequence rate is 1 Mbps. So this is my FB. Okay, that is equal to 1 Mbps. You do not have to look at this carrier frequency rate. Okay, this is just given for reference purpose. It is not used anywhere in the question. Why? Because it is given that the carrier frequency rate is always higher. As you all know, frequency of carrier is always higher than your actual data rate. So it is just given that my frequency of carrier is 100 megahertz, in which 1 Mbps of data. Now 1 Mbps is equivalent to 1 megahertz. So in 100 megahertz, 1 megahertz is of data. That is what is given in the question. Do not confuse yourself with this 100 megahertz and take that value to solve the question. Okay. Now second thing, 1 Mbps is equivalent to 1 megahertz. How? Because in 1 Mbps it is 1 megabits per second. That is how many megabits of data is sent in 1 second. And the definition of frequency is how many data is times it goes from high to low in 1 second. So basically the definition of both is same. That is why I can say that 1 Mbps is equivalent to 1 megahertz. So if in question it is given 2 Mbps, you can take it to 2 megahertz. But if in question your bit rate is given higher than your carrier transmission rate, then you can assume that the question is wrong, or you have to find your Rmax. Rmax, we saw it in the first video. In that sense, you have to find the Rmax. There you will get the rate of transmission, the maximum transmission possible, and then you have to further solve the question. So in this, that is not the case. So let's proceed. FB equals to 1 megahertz. So now I need to find my time, TB, transmission time. That is always equal to 1 upon FB. So 1 upon 1 megahertz. 1 megahertz is 10 raised to 6. And this comes out to be 1 microsecond. Now for 8 array system, PSK system, okay. This 8 is the value of M. Okay. Now my formula is 2 raised to n is equal to M. So I can write 2 raised to n is equal to 8. 2 raised to n is equal to 8 in powers of 2 is nothing but 2 raised to 3. That means my n is equal to 3. Okay. Now I have to find symbol duration. Okay, symbol duration is nothing but n into TB. My n is 3 and my TB is 1 microsecond. So this comes out to be 3 microsecond. Okay. Now my symbol rate, which I have to find in the question. Okay. Symbol rate and bandwidth requirement. So symbol rate, that is nothing but 1 upon my symbol duration. Okay, my symbol duration came out to be 3 microseconds. So I will write 1 upon 3 microseconds, that is 1 upon 3 into 10 raised to minus 6, and this comes out to be 333.33 symbol per second. This is the unit. Okay, make sure you write the correct unit. Then next we have bandwidth. Bandwidth is equal to 2 into FB upon N. 2 into my FB is 1 megahertz. Okay, so I will write 2 into 1 into 10 raised to 6, of course, upon N, which is 3. Solve this and you will get the value of bandwidth. Since this is bandwidth, its units will be in hertz. So answer will be kilohertz or megahertz something. Now let's solve for 16 ARY. So for 16 ARY, my M is equal to 16, my 2 raised to N equals to M. So 2 raised to N is equal to 16, 2 raised to N is equal to 2 raised to 4, my N becomes 4. First thing we have to do is symbol duration. That will be equal to N into TB, which will be equal to 4 into TB is same as previous, 1 microsecond, which comes out to be 4 microseconds. Then we need to find symbol rate, which will be 1 upon 4 microseconds, and then you will get the answer. And then we need to find bandwidth, which is again the formula remains same, 2FB upon N, and whatever you have, 2 into FB is 1 megahertz upon N is 4. So solve it and you will get the value of bandwidth. The next type of question encountered here is we have to sketch the Psk and Qpsk signal. Psk is phase shift keying, and Qpsk is quaternary phase shift keying. So we have been given the signal, which is 1 0 0 1 1 0 1 0. So first let's sketch Psk. Sometimes it is also called as Bpsk. Okay, so what happens in this? Now this is not digital communication, in the sense that this is not a digital output, this is a analog signal. So we will have sine and cosine waves here. So for 1, it starts from high, goes halfway low, then starts low, goes high. So in this one, I have this halfway division. So it will start high, go halfway, in halfway it will change, and then it will start from low, and then halfway it will go high. For 0, exactly opposite happens. It starts from low, goes high, then comes back low. Again 0 is encountered, starts from low, goes high, then comes back to low. Then 1 is encountered. What will happen? Start from high, go halfway low, then go high again. Basically a normal sine wave sort of thing. 1 is encountered, start from high, go low, high. 0 is encountered, goes low, starts from low, goes high, comes back low. 1 is encountered, starts from high, goes halfway low, then becomes high again. 0 is encountered, starts from low, goes high, comes back. So this was my Psk, or sometimes also called as Bpsk output. Now let's draw for Qpsk, that is quaternary phase shift keying. In quaternary phase shift keying, two adjacent signals form one angle. Basically, a combination of 1 and 0 is given as 180 degree phase, and a combination of 0 and 1 is given as 90 degree phase. Okay, so firstly this 1 and 0 will form 180 degree. This 0 and 1 will be 90 degrees. 1 and 0 again 180 degrees. 1 and 0 again 180 degrees. So for this 180 degree, okay, let's sketch. 1 starts from 0, and in this halfway, okay, in this halfway it covers 180 degree, and then the remaining one again it will be covering 180 degree. So for this one it covers the whole of 180 degree, I can say, and 0 the same thing applies because these two form one pair. So this will also start and then cover 180. So this is 180, 180, 180, 180. Now 0, 1, 0, 1 together they are 90 degrees. So what will happen now is they will just cover 90 degrees. So they will start from this part, then just cover 90 degrees up, 90 degrees down, then again 90 degrees up, halfway, that is why 90 degrees, then 90 degrees up. Then this one, since it forms a pair, again it will just cover 90 degrees halfway, then 90 degrees again, then 90 degrees, and then 90 degrees. So I hope you understand what I am talking about. This was full 180, but this is just half, that is 90 degrees, because 0 and 1 together form a pair of 90 degrees. So halfway 90, this halfway, halfway, halfway. So in one block it will change its position 4 times, halfway, 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 and one thing to note, it will start from high. Then this one again, since it is a pair with this 0 and it is in this 90 degree block, it will have 90, halfway, 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 4 times. Then now 1 and 0 are encountered, which is 180 degrees. So yes, they will come down right here and then a full 180 degree will be formed. So 180, 180, 180, 180. So this two blocks, they get completed. Then again a pair of 1 and 0 is encountered. So this will be again 180, 180, 180 and 180. So this was the output for Psk and Qpsk signal. See you all in the next video. Thank you.